Hi girls, in today's lesson we'll be focusing on graphing linear equations. This was a topic that we actually explored last year, and it was all about just graphing lines by using table of values and identifying what those equations are and so forth. So let's just have a read it for a start. A relationship between two variables, x and y, whose graph is a straight line is called a linear relationship. The expression of that relationship is an algebraic formula such as y equals 3x plus 2, and that's called a linear equation. So these are all about lines. Now in your book, I want you to write down exercise 203, graphing linear equations. We'll start with question 1D as an example. Question 1, graph each linear equation on a number plane and write x-intercept and y-intercept. Okay, and I'm going to explain to you what these are after we graph this. So, in question 1, all they ask you to do, or really require you to do, is draw out a table of values. So remember how we drew x and y before, like so, and we had 3 values here. Okay, you can pick 1, 2, 3, but I'm going to pick 0, 1, and 2. Okay. Now, after we do that, okay, this is for question 1D, we're going to substitute in 0 into that equation. So once we do that, we get y equals to minus 2 times 0 minus 2. So minus 2 times 0 is 0, subtracted by 2, well, that's just negative 2. So I'm going to write in negative 2 there. Then we can substitute in 1 as x. So y would equal to minus 2 times x, but instead of x, we write 1, and minus 2. Minus 2 times 1 is going to be negative 2. Negative 2 minus 2 is negative 4. Now, the last bit, y equals to minus 2 times the number 2 minus 2. Minus 2 times 2 is negative 4. Minus another 2 would be negative 6. So I'm going to put these two other values in here. Okay. Now each of these are basically a coordinate, okay, or a pair of coordinates. So I'm going to graph these right now. So I will draw my axes like so. All right. So 0, negative 2 means we're not going to go left or right at all. We're just going to stay put where we are. And then a negative 2 here as a y value means go down by 2. Here we go. Okay, so that means there's a point there. And 1, negative 4 is going to be here. So 1 right and 4 down. Whereas 2, negative 6 will be 2 right and 6 down. Okay. Oh, I forgot to grab that other point. So what was it again? 1, negative 4 here, sorry, and then 2, negative 6, which is down here. And all we got to do here is just use a ruler to make a straight line. And this has to be to scale, otherwise it wouldn't work for you. Okay? So make sure you have your grid book, and make sure you're writing all this in your grid book. Okay, so extend the line so that it reaches like the top and the bottom bit of your axes. Okay, as far as that, and then draw arrows at the end. Make sure you do that, and label your y and x here. Now, what it's asking you to do for this particular question is part I, find its x-intercept and find its y-intercept after we graphed it. So we've graphed it here, and for part I, okay, let me just put this all over here. Here we go. All right, so for part I, the x-intercept, okay, that's what it's asking for, right? So its x-intercept will be at where it crosses the x-axis. So this is the x-axis, okay? Our x-intercept will be right here. I'm going to put that in red, right there. And that point there is a number, negative 1, 0, because we're going left by 1 and 0 up or down. Okay? Now let's have a go at the next particular question. The next particular question is asking us about where the y-intercept is. So this is where it will cross the y-axis, right? So now, in this case, the y-intercept here is going to be this point here, which is going to be 0, -2. Okay, so that's the coordinate of your y-intercept, okay, which is where it crosses the y-axis. Right? I hope that helps you do the other questions there. I'm going to move on to the next concept, so pause the screen if you need to write this down. The next thing we're going to do is testing if a point lies on a line, and we've done this once again before. So I want you to write down the summary as well as that little title there. So a point lies on a line if its coordinates x and y satisfy the equation of a line. Let me demonstrate that using the first question here. So write question 2a. Okay. So 2a says y equals to 2x minus 5. Now we're testing whether the point 3, -1 lies on the line. So this is our x value, and this is our y value. And so every equation that we write has a left-hand side as well as a right-hand side of the equal sign. So we're going to start off with the left-hand side. Okay, the left-hand side being this stuff I'm highlighting right now, which is y. Okay. Now we're asking ourselves, what's the y value that they also gave us? Okay, that y value given to us is 3, -1. Okay, so that's going to be the -1 part of that coordinate. So we'll have -1 replaced there. Whereas the right-hand side is this part, 2x minus 5. Now ask yourself, what is the x value here that they gave us? It is number 3. So we're going to do 2 times 3 minus 5. Okay? So that will be 6 minus 5, which is 1. Now, have a look. Are these two the same values? If they are, then they satisfy the equation. If they're not, then that means it doesn't satisfy. So if it doesn't satisfy the equation and they're not equal, okay, we can say, therefore, LHS is not equal to, so an equal sign with a line, strike through it, and that's not equal to RHS. And then what we do is we say, therefore, 3, -1 does not lie on the line. Okay, I hope this rings a bell for you because we've done a lot of these last year, so this should be very, very simple to you now. Okay, so what that basically means is if I have a line, right? Okay, I'm going to guess that line looks like this. I think it looks like that. And 3, -1, okay, is somewhere around, maybe around here, okay, I believe. And what it's saying is that point does not lie on that line, okay? And I mean, if I had a point that I'm substituting and eventually I got, let's say, you know, 2 values are the same, then that means the point lies on the line like that. Okay, just geometrically speaking, that's what that means. All right. E says x plus y equals to 5. So what's different about this equation is x and y are now on the left side, whereas on the right side, I've only got a number there. So the only time I have to substitute something is when I deal with the left-hand side, because my variables are there. So that's what we're starting off with. We're starting with the left-hand side, and x and y are 3 and -1. So if we do 3 plus -1, the negative would override the positive. So we have 3 minus 1 instead, which is simply 2. Your right-hand side of the equation is only just the 5. We don't have to substitute anything in there at all. So, what does that mean? Well, that just means that, therefore, left-hand side is not equal to the right-hand side. And therefore 3 -1 does not lie on the line. Okay, so you know what, I've done 2 examples where it doesn't lie on the line. I should really do an example where it does lie on the line. Okay, I'm just going to erase part A and I'm going to do question B because I think it does. Okay, so I'll do an extra question. right? So for part B, I've got x minus y equals to 4. And so my left-hand side is x minus y. But x in this case is 3. Then I'm going to write that minus sign. Now y in this case is negative 1. So what happens when I write minus of negative 1 like that is that I have 3 plus 1. Okay, the negatives, they both change to plus. So 3 plus 1 now is 4. And what do you notice with the right-hand side of this equation? It is also 4. So we can say now that therefore the left-hand side equals the right-hand side. And also therefore, since they are the same numbers, we can now say that the point 3, negative 1 lies on the line. Okay? Right, pause the screen because I'm going to move on again. Okay. The next concept we're looking at is horizontal and vertical lines. Again, something we explored last year. Now, the equation of a horizontal line, so this line here, is a line that has all the same y values, so the same height above the x-axis, basically. Okay, where the y value in this case is c. Okay, so we call it y equals c. And I'm just going to give you an example. If I had a number, let's say number 1 there, this line would be called y equals to 1. Okay, I'm just letting you know that. So you can write that down as well as this, and now I'm going to explain this part. So the equation of a vertical line is of the form x equals c. So if c is a number here on the x-axis, then we call this line x equals c because it is c units to the right of the y-axis. So if I had the number, let's say 6 here, then this line is called x equals 6. If I had a line here that is at minus 1, then this will be x equals minus 1. Okay, so copy down those two diagrams as well as the notes here into your book. And now I'm going to move on to the question. So pause the screen if you need to. Right, I'm going to move on. Question 4. Find the equation of each line below. So we've got A, B, and where's C? Oh, C is here and D is there. Let's start off with question A. Now, an easy way to actually look at whether you have to do x equals something or y equals something is by looking at where the line actually intersects the axes. So see how the axes are here? I've got the x-axis and the y-axis. Okay? Now ask yourself this. What does the line A, the purple line, cross? Does it cross the x-axis or the y-axis? Let's just draw it down. Look, if I just draw over it, which one does it cross? It crosses here. And that axis is the x-axis. So we say x equals to that number there, which is the number -4. Now for question B, let's do the same thing. Question B is also crossing here the x-axis. Okay, it's crossing the next value here, which is number 1. Okay, so both vertical lines are to start with x equals something. Now we can move on with the horizontal lines. So for question C, this horizontal line, where's that crossing? It's crossing the y-axis, first of all, and the y value it's crossing at is 5. So we say y equals 5. Part D, using a similar strategy, we would identify the y value there, and y would equal to -3. Okay, I'm going to move on. Question 5. Graph each set of lines on number plane. I'll just do the first question. So on a number plane, all you have to do is graph one this big, or you can graph it smaller if you wanted to, but you must make it big enough so that it contains all these graphs here. So x equals 2.5. When we graph this, we identify the value on our x-axis right here, and 2.5 will be 2.5 squares to the right. So we'll say this is 2.5.
like that. And we'll graph that line. So I'll make it a purple maybe, there. And that's our line, right? Now, y equals -3 means look at the y-axis, find the y value of -3. That means go down by 3, which is here. Okay? And then draw a line perpendicular to that, so this way. And that will contain all y values that are -3. Then, y equals 1. Y equals 1 is 1 above the x-axis, so over here. And we're going to draw a horizontal line, like that. Oops. And that's it. So it'd be a good idea to actually label what these graphs are. So on your page, write x equals 2.5, y equals 1, and y equals -3 once you're done. And that'll help you do question B later on for homework. Right, I'm going to move on to the last question, so pause the screen if you need to. Question 6. Find the equation that is horizontal and passes through the y-axis at 2. So in order to actually do this, you've got to visualize where these things pass through. So by doing this, which is graphing out my x-axis and y-axis, just temporarily, like that. Okay, just so that I can see what it's asking me to do. So part A says horizontal and passes through the y-axis at 2. So my y-axis is here. That's this line. Okay. So at the y-axis, the number 2 will be right there. Okay. I'll plot that there. Now there is a line that is horizontal passing through that. Okay. So what do we call that? It's going to pass through the y-axis. So the equation here should be y equals 2. Okay. Now it's vertical with an x-intercept of 4 for B. So if it has an x-intercept of 4, that means it passes through the x-axis at the number 4, right there. Now if it's vertical, like this, that's the line we're finding the equation for. And since it's passing through x equals 4, our equation is x equals 4. Right? Part C. Parallel to the y-axis and passes through the point -1, 4. So here's my y-axis, and if I have a line parallel to the y-axis, I'm looking at something like this. Okay, where it's the same direction. That's what it's saying. But it passes through the point -1, 4. So -1, 4, if I was to just plot that out, that's here. Okay, there's my point -1, 4. I have a line that passes through that dot, going through that. Now, which axis does it hit? It's parallel to the y-axis, but it hits the x-axis here. Okay, hits the x-axis. So this vertical line that I have to find the equation for hits the x-axis, and it hits x equals to -1. So the equation of this is x equals -1. Part D, which says parallel to the x-axis, meaning that it's a line that is the same direction as this line. So it could be this line, could be this line, etc. Has to pass through 0, -2. So 0, -2 means 2 down from the origin, 0 left to right. So 2 down would mean somewhere here. Okay? And it's parallel to the x-axis, so it has to be something like this. So what kind of axis does it cross though when you draw it? It crosses this number here, which is on the y-axis. So y would equal to -2. All right. E is slightly more challenging. E says, let me just rub this out. E says 3 units above the x-axis. Okay, so 3 units above the x-axis is right there. If I continue to draw any kind of dots which are 3 units above the x-axis, like that, these are all 3 units, right? Okay, if I just draw more and more dots like that, and then I just join them up to make a straight line. Okay, all of these are 3 units above the x-axis. So what do you call this if it passes through a y value of 3? It is just called y equals to 3. for question F. We've got 1 unit to the left of the y-axis. So there's my y-axis, and if I just count 1 unit to the right, 1 unit to the left, that means here. 1 unit left, 1 unit left, 1 unit left. And let's just say we have all these dots here, which are 1 unit to the left of the y-axis. If you draw them up, it will cross this point here, which is a y value of -1. So our answer here is y equals -1. G, drawn through the points -1,6 and 2,6. -1,6 will be here, okay, right there. And then 2,6 will be here. So those are my two values there. And there's a line that passes through those two dots. So if I just join them up and extend them, it passes the y-axis at 6. So that's called y equals 6. Okay, lucky last, H. It is drawn through the points -1,8 and -1,2. So -1,8 means, if I just extend this, hold on, give me 1 second. Right there. So 8 will be this high. Hold on. Okay, so if I count 8 upwards, this is 4 units up, another 4 units up will be here. So this is 8 units upwards, and I have a value or a coordinate which is 1 to the left and 8 upwards, so that will be here. Whereas my other value is 1 to the left and 2 up, so that will be here, right? Now I have a line that actually joins up those two dots, like that. So what axis does it cross? It crosses this x-axis here, at that point, okay? And that point is called x equals to -1. So all of these coordinates here would have x values of -1.